Good morning, Ma'am Almiranias. Good morning, everyone. We are Group 6 Quadrapool, and today we will be presenting our three proposed titles. Before we begin, let us introduce ourselves. Hi, my name is Serjana Macalatas. I'm the project leader. I manage our project, lead the team, and also take charge of the technical development, especially in coding and system logic.
The name Civilian H. Laura, developer.
Good day everyone, and Ma'am Alni. My name is John Ivan Mariano, and my role in our group is the one of the developer, and I am responsible for designing, coding, and ensuring that our project functions properly. Thank you.
Good day, everyone. I am Diana Tigamon, a research and documentation analyst and one of the developers of Quadrapool.
Together, we believe in four minds and one logic, working as one team to create regional and functional solutions.
Pool. I will present our project titled Smart Pedestrian Alert Prototype SPOP, an inclusive Arduino-based prototype for safer crossing. The Smart Pedestrian Alert Prototype is an inclusive Arduino-based system designed to improve pedestrian safety at road crossings. It uses a sensor-based detection, real-time signaling, and a multi-sensory feedback to assist pedestrians while also alerting the drivers. Unlike traditional pedestrian crossings that rely on fixed timers, our system adapts to a real-time situations. This makes it more responsive and effective in preventing accidents. Moreover, this project is designed with inclusivity in mind. It incorporates features for persons with disabilities, such as audio alerts, visual indicators, and a braille integrated surfaces that allows a safer and more independent road crossing. With this innovation, we aim to create a safer and more accessible environment for all the pedestrians. Imagine trying to cross a busy road with no traffic light, no clear signal, and cars just keep coming. Now imagine experiencing that every day, especially if you cannot see or hear properly. This situation is a reality for many pedestrians, particularly here in the Philippines where some roads lack a proper crossing systems. Good day everyone, I am Diana Tigaman, a documentation and research analyst and one of the developers of Quadrapool. I will present our project titled Smart Pedestrian Alert Prototype SPOP, an inclusive Arduino-based prototype for safer crossing. The Smart Pedestrian Alert Prototype is an inclusive Arduino-based system designed to improve pedestrian safety at road crossings. It uses a sensor-based detection, real-time signaling, and a multi-sensory feedback to assist pedestrians while also alerting the drivers. Unlike traditional pedestrian crossings that rely on fixed timers, our system adapts to a real-time situations. This makes it more responsive and effective in preventing accidents. Moreover, this project is designed with inclusivity in mind. It incorporates features for persons with disabilities, such as audio alerts, visual indicators, and a braille integrated surfaces that allows a safer and more independent road crossing. With this innovation, we aim to create a safer and more accessible environment for all the pedestrians.
Pedestrian safety is still a big issue here in the Philippines. Some accidents happen when crossing the roads because of how unsafe it is, and the drivers sometimes don't yield. Traditional pedestrians send signals that are fixed. They don't adapt to real-time situations because there is a system that they are following there where there is a timer. That is why we propose the Smart Pedestrian Alert Prototype, or STAP in short. It is designed to detect pedestrians, manage signals, and alert both drivers and pedestrians. What makes it unique? Unique, if you may ask. What makes it unique is that the inclusivity of this project. We are adding audio, visual, and even tactile feedback so person with disabilities like problems in their eyesight or hearing, and other things, they are welcome to, or they are they can feel more safe when crossing the roads, because there are multiple features that can help each individuals that have different problems. So to guide our study, we ask four key questions. Those are, let us start with the first one. First, how can sensors make it easier to detect pedestrians? Second, how can a prototype send real-time alerts to both drivers and pedestrians? Third, how well do audio signals, braille integrated features, and visual indicators help pedestrians who are hearing and visually challenged? And lastly, how can the system make places without traffic lights safer? These questions define the problem we're solving and the direction of, our prototype.
In this project, we have two objectives, which is the general and the specific objective. The general objective, we have to develop an inclusive smart pedestrian alert prototype, or SPAP, that enhances pedestrian safety and accessibility. And for the specific objectives, first is to design a sensor-based system for detecting pedestrians. Second is to implement real-time alert mechanisms for both pedestrians and drivers. Third is to integrate multi-sensory features such as audio, visual, and braille outputs. And lastly is to evaluate the effectiveness of the prototype in improving safety in non-signalized crossing areas.
The Smart Pedestrians Alert prototype is an Arduino-based system designed to improve pedestrian safety in areas without traffic signals. It uses sensors to detect pedestrians and provide real-time alert through LED lights, audio signals, and voice prompt to guide both pedestrians and drivers. This prototype also promotes inclusivity by incorporating features such as braille markings, audio cue, and visual indicators to assist individuals with visual and hearing impairment. By integrating sensor-based detections and multi-sensory feedback, the system aims to create a safer and more accessible pedestrian crossing environment. It enhances situational awareness by delivering timely alert to both pedestrians and motorists, thereby improving the response time and reducing the risk of accidents in areas lacking regulated traffic control.
Tools and requirements of the SPAP. First, let us discuss the hardware requirements. The first one is the basic requirements, or the hardware tools that we will be needing for building this prototype. Definitely, or obviously, we're going to use the Arduino Uno for the inputs and outputs. The PIR sensor, that so that it can detect the pedestrian if someone would like to walk or cross that road, but it's not their turn yet. So it will send an alert or an audio for them to be reminded that it is not their turn yet to walk. The third one is the 7-segment display, and this is the timer that counts, or count down the duration of how long the pedestrian can walk or cross the road. But the 7 seconds can be changed in the future, or depending on how long is the pedestrian, because some places are short or longer. So it can be 10 seconds or 15 seconds, depending on the place. The fourth one is the LED strip lights. We will be putting these strip lights to the ground, and this is specifically for the pedestrian. It will send, or it will glow green or red for the pedestrian, not for the drivers, so that they are aware, even though if they are using their cell phones. So that because some people use cell phones most of the time, even when crossing the roads, and the street lights, or the ground lights, helps the people who has disability as well, with their necks, they don't have to look upward so that nakita lang nila yung stoplight or yung timer. But this will serve as a tool then to help them even though when they're using their phones or when they're looking down, they can see whenever it is safe to wait when it is their turn or safe to walk or cross the road. The next one is the traffic light module. So this is like the similarly to the stoplight that we are seeing, the red, green, and the yellow one. We will be using this for the opposite signal for the drivers. So these are mainly, or the purpose of this is for the drivers because the ground or the strip lights, the the ground lights, we cannot see that because they are in their trucks or their vehicles. So but it doesn't really matter because those are mainly for the pedestrian and the stoplight, the traffic light module is for the drivers. The next one is the push button on post manual pedestrian request. So this will serve as the so we are planning to put post on both pavements that if the user or I mean the if a person click that button, then the timer will be activated for them to cross the road. And then all the other basic tools and the hardwares such as breadboard or the motherboard, jumper wires, transistors, and etc. Let us proceed with the next requirement, the software requirements. We're going to use Arduino IDE for coding and the C++ programming language for logic for the logic. The last one is the functional requirements, and these are the functions for the prototype to work. The first one is detect pedestrian's presence via sensor or button press, and if a person push the button, then the timer will be activated for the pedestrian, and and the duration is 7 seconds. And for the drivers, the traffic module light or the common stop light that we see in roads, it will turn red for the driver so the pedestrians can cross. And the next one is the enforced fairness. We have thought that it will be unfair for the drivers if the person or the pedestrian can cross freely or whenever they want by pushing the button, and the timer will start 7 seconds, and as long as there is someone pushing the button, the timer will be activated. And we don't want that because it will be biased for the pedestrian and it can cause traffic for the drivers. So the solution for that is that we will be doing, or there will be a 2 minutes delay before the activation of the button. So if someone pushed the button for the first time and there there is a next batch who wants to cross again, they cannot, or the button will not be activated yet because there will be a delay. So the drivers can cross, and it will be a smooth um system, I think. The next one is provide buzzer, LED, audio feedback for inclusivity. And these are the features that will help that will help people, especially with the PWDs or disabilities. The last one is the ground strip lights turn green or red to guide pedestrians visually.
As shown on the screen, this is the simulation of our smart pedestrian alert prototype. In this setup, a pedestrian is detected at the crossing area using sensors embedded near or along the pedestrian lane. Once a pedestrian is detected, this system activates the traffic signal that turning it to red for vehicles as seen in the image, which signals drivers to stop. At the same time, the pedestrian is guided by visual indicators such as the green pathway lights on the crosswalk, which indicate that it is safe to cross. In addition to visual signals, the system also provides audio alerts and is designed with braille integrated surfaces to assist visually and hearing impaired individuals. This ensures that the system is not only functional but also inclusive for all users. Through this setup, the prototype demonstrates how a technology can create a safer, more organized, and a crossing experience even in areas without traffic lights. This is the expected outcome of our project, an efficient, responsive, and an inclusive pedestrian alert system.
And for our second proposal is a game titled Fate and Fence Slate Fuel Edition. Fate and Fence Slate Fuel Edition is a fast-paced digital game designed to challenge players' speed, focus, and strategic thinking. In the game, players control a character that collects items while avoiding hazards, where each action directly affects the character's health. The gameplay continues until the health is fully depleted, encouraging careful decision-making and survival-based strategies. The game features smooth mechanics, responsive control, and engaging interactions. It also incorporates elements inspired by the Philippine mythology, adding cultural depth and uniqueness to the overall experience. The game aims to provide an immersive, challenging, and mentally stimulating environments that enhance player reaction times and critical thinking skills.
Problem statement. Most digital games today rely on fixed time limits. That means players are pressured to finish tasks quickly. I mean, some of them, but they don't get much chance to plan or think strategically because there is only limited time. This often makes the gameplay repetitive since success depends only on the reaction speed. Our game, on the other hand, Faith and Touch Rage Fuel Edition addresses this by using a health-based system instead of time limits. Every decision matters, and that means that you have to think carefully because every move, every mistakes, every each mistake, I mean, can affect your survival, maybe in the future and even in the present of the gameplay. That is why this makes the game more engaging and forces players to think under pressure. Because as the game continue, the difficulty of the game increases, which gives more pressure to the players. And it also increases their some chemicals of of a person because they are under pressure. It can be a dopamine or something, some happy chemicals, and yeah, and so on. Another unique aspect is the integration of a unique theme called Philippine mythology. We have decided, or this game uses characters such as the Banananggal as the character of the player, and we also use other cultural themes to make the game more relatable and original. We use this kind of theme to make it original, to show some originality and some uniqueness. And to guide our study, we ask 4 questions, and hopefully we will be able to answer this at the end of the project. The first one is health how does how does a health-based gameplay system influence player engagement compared to traditional time-limited mechanics? Second, in what ways does the game promote strategic thinking and decision making under pressure? How effective are the integrated thematic elements like the Philippine mythology in enhancing player experience? And lastly, how effective is the overall game design in terms of usability, performance, and player satisfaction?
Now, let's move on to the objectives for this game, Faith and Fetch. Our general objective is to design and develop a health-based action strategy game that enhances the player engagement and cognitive skills. To achieve this, we also have established several specific objectives. The first one is to develop a fast-paced game that combines action and strategy. Second, to implement an item system where each object affects the player's health and gameplay. Third one is to incorporate thematic elements inspired by Philippine mythology or the Manananggal. And the fourth one, to promote decision making and strategic thinking under pressure. And the last one is to create a replayable and enjoyable gaming experience.
And for the project description of this game, this is a 2D digital game that combines action and survival gameplay. In this game, players collect items, avoid obstacles, and manage their health to get the highest possible score. The game was created using the game will be created using C++ with responsive controls and smooth performance to provide a better gaming experience. It also uses creative themes that make the game more unique and engaging. Overall, this project highlights our game development skills while creating a fun and challenging game for the players.
Tools and requirements. To develop Paid and Fetch, we identified the tools and requirements needed. For software requirements, we will be needing C++ programming language for the core logic and mechanics, Raylib as our library for handling the graphics, rendering, animations, and hardware interaction and other and etc. And for the IDE, we're going to use Visual Studio and a compiler. For the hardware requirements, we are we just need like minimal requirements such as laptop or PC that can handle C++ and RLib, and input devices such as keyboard for controlling the the character of the game. Next is the functional requirements. Here is how the game works. The players control a character with smooth movement. They collect good items falling from the sky, and each items have different effects to the player. Some items give more points, and some items can re can give that player more healths and or like revive their one heart and etc. At the same time, they must avoid bad items that are falling from the sky, and spikes or snakes or other things that they have to be careful on the ground. That makes it more exciting because they don't only have to mm, be careful above but also underground. The player has three hearts and different hazards reduce health differently. As points increase, the game difficulty increases. And finally, we integrate Philippine mythology and creative um, elements to make the game culturally relevant and unique.
An expected outcome of this game is fully functional action strategy game that features a health-based gameplay system. The game is designed to provide an engaging and challenging experience while encouraging players to improve their decision-making, focus, and action skills. It is expected to demonstrate that a health-based system can enhance gameplay by promoting strategic thinking and increasing player engagement. The final output will be playable and enjoyable digital game.
And for our last proposed project entitled EduFinance Students Expense Management and Tracker System, It is a web-based platform designed to help students effectively manage their finances. It allows users to track expenses, monitor bills, set reminders, and organize their financial activities in real time. It is developed with simplicity and accessibility in mind. The system supports multiple users and provides a secure way to manage personal financial data. It is specifically tailored to meet the needs of students, offering an easy to use interface for better financial control. And overall, the system aims to promote financial awareness, discipline, and responsible money management among the students.
Problem statement of Edu Finance. Managing finances is a common challenge for students nowadays. Many don't have a structured way of organizing or recording their finances, their daily expenses, bills, and etc., which makes it harder for them to see where their money is going. And bills and due dates are often forgotten, which leads to penalties or financial stress because of school activities, chores at house, and maybe even work. Our project EduFinance is a project is a web-based student financial management system designed to address this problem. It allows students to record their expenses, track bills, remind them to pay their due dates, maybe rent and other things, and importantly, we it will provide a clear summaries of financial activities to support better decision making. To guide your study, we have created five key questions. First is how can a web-based student financial management system be developed to help students manage their finances efficiently? Second, how can the system enable students to record and categorize their daily expenses? Third, how can the system assist students in tracking bills and setting reminders for due dates? Fourth, how can the platform provide clear summaries of students' financial activities to support better decision making? And lastly, how acceptable is the developed system in terms of usability, functionality, reliability, and security? These questions define the problem we are solving and the goals of EduFinance.
The general objective is to develop a web-based student financial management system that helps students effectively manage and track their finances. Specific objective is to create a simple and user-friendly platform for financial management, to allow students to record and categorize expenses, to help track bills and monitor due dates, to provide clear financial summaries for better decision making, and lastly, to ensure that the system is reliable, secure, and easy to use. This system is designed to help students take better control of their money by making financial tracking simple and organized. This allows users to easily monitor their expenses, manage upcoming bills, and understand their overall financial situation through clear summaries. The goal is to support smarter spending habits and improve financial awareness in daily student life.
Now, let us proceed to the project description. EduFinance is a multi-user web-based platform that is designed to help students manage their personal financial data efficiently. In this system, users can create their own accounts, allowing them to securely access and organize their financial informations. Each user can record their daily expenses and categorize them into groups such as food, transportation, and even school supplies. In addition, the system also allows users to track their bills along with their corresponding due dates and also includes a built-in indicators that notify users of upcoming or overdue payments, helping them stay organized and avoid missed obligations. Furthermore, the platform generates a summary and simple reports that enable users to better understand their spending habits and financial activities. The system is designed to be simple, responsive, and easy to navigate, making it accessible even for users with minimal technical knowledge. Overall, EduFinance provides a convenient and structured solution for students to monitor, manage, and improve their finances.
For the tools and requirements of this project, we have two requirements, which is the hardware and the software. And for the hardware requirements of our project, we need a computer or a laptop, a stable internet connection, a keyboard and a mouse, and at least 4 gig RAM of smooth performance. And for the software requirements, we need a code editor such as Visual Studio Code, a web browser like Google Chrome, and front-end technologies such as HTML, CSS, and JavaScript. We also need a backend language like PHP or Node.js, and a database management system like MySQL, and an operating system such as Windows, macOS, or Linux. So these are the requirements that are essential for the developing and running the project properly. And lastly, for the expected output, here you can see the proposed output for our system's UI or the dashboard. And the system is expected to display a user-friendly dashboard that provides an overview of the student's finances, including total balance, monthly expenses, savings, progress, bill status, and upcoming due dates. It should allow easy navigation, efficient tracking of finances, and timely reminders for better money management. Thank you so much.
Each of these projects reflects our goal of creating solutions that are functional, original, and impactful to our community. We are Group 6 Quadrapool, and we stand united as four minds and one logic. Thank you, and thank you very much.